All right, in our third video, we are going to do a couple practice problems that use both reciprocal and quotient identities. So we're going to kind of try to tie it all together in this one. And to help with that, I've kind of got our reciprocal identities, our quotient identities, and our Pythagorean identities over here to the side, because we're going to keep referencing these throughout these problems. So if we start with this one says secant x cotangent x minus sine x. Well, whenever we're doing these, one of my rules of thumb is I like to write everything in terms of sine and cosine. So we know secant is 1 over cosine, cotangent is cosine over sine, and then we're subtracting sine, which is already in terms of sine, right? So whenever I am looking at this part over here, we see that we have cosine over cosine, which is going to cancel. So that simplifies to 1 over sine x minus sine x. Now, if I've got kind of these two different values here, and I'm trying to get a common denominator, this sine x over here needs to have a denominator of sine x. So I'm going to multiply by sine x over sine x to give it the denominator it needs. So then I've got 1 over sine x minus sine squared x over sine x, because this right here becomes sine squared x. And then I have everything 1 minus sine squared x. If I've got the common denominator, I can just write it all over that denominator. Now I'm going to come up here and I'm going to recopy what we have. We have 1 minus sine squared x over sine x. Now here's what we need to recognize. 1 minus sine squared x is not directly in any of these identities, but I'm going to pull this identity right here and I'm going to write it. If I have sine squared x plus cosine squared x equals 1, what would happen if we subtracted sine squared x from each side of this? And I'm kind of writing over there on my lines, but then we'd have cosine squared x equals 1 minus sine squared x. So while it might not be immediately evident, this is just one of our Pythagorean identities that's been moved around a little bit. It's been manipulated. So therefore my numerator, that 1 minus sine squared x, I'm going to substitute in cosine squared x. And then what we have is this. It might be a little bit hard to see in this form, but cosine squared x is just cosine x times cosine x, and then it's all over sine x. So what we can do is I can look at that right there. Cosine x over sine x, using our quotient identities, is just cotangent x. So that part is going to simplify to cotangent x, and then I have cosine x right there. So I believe this is going to be the simplest form of our answer that we can get. There's example 1. Let's do example 2. Now in this problem, it's really not that complicated mathematically, but there's just something that we need to see. And this is one of those things that the more of these identity problems you do, you'll kind of start to see it. But you might recognize that we have a sine x there and we have a sine x there. So we kind of have two terms. I can think of this as a term plus this over here, but both of those have a sine x. So what I can do in this case is I can factor sine x out of both. So once I factor a sine x out of this, you're left with the cosine squared x. And once I factor a sine x out of this, it becomes sine squared x. Well, then you probably recognize, oh, cosine squared x plus sine squared x, that's just a big old fancy 1. So we have sine x times 1, which is really just sine x, okay? So this one, like I said, it's not that complicated, but it's recognizing that first step of factoring a sine x out of both. Once you see that, it's really simple. Now let's do our third and final example. This one's a little bit tougher. So whenever I look at this one, I'm looking at this problem and I see subtraction. We've got a fraction over here and a fraction over here. And a lot of times on this type of problem, when you got those two different fractions, you're going to want to get your common denominator. So if you're good with like simplifying rational expressions, you might recognize what our common denominator is going to be. It's going to be 1 plus sine x times 1 minus sine x, because this one doesn't have a 1 plus sine x and this one doesn't have a 1 minus sine x. So the way we get the denominator that we want is I multiply this side by 1 minus sine x over 1 minus sine x, and then I multiply this side by 1 plus sine x over 1 plus sine x. And whenever I do that, we can man, we could do a few different things here, but I'm just going to write it as one big fraction first, because notice we've got the same denominator on both sides now, so I'm just going to write it over 1 plus sine x and 1 minus sine x. Now, this part right here, I'm just going to do 1 plus sine x times cosine x, and then I've still got my minus, and then I've got cosine x, 1 minus sine x. Now what I'm going to do is I'm going to do some distribution. I'm going to go and I'm going to take this minus cosine x and go. So over here on the left, cosine x plus cosine x sine x. So cosine x times 1, and then cosine x times sine x. And then now I'm going to do the part over here. So I've got this minus cosine x that I'm going to distribute in. Minus cosine x times 1 is minus cosine x, and then minus cosine x times minus sine x, and negative times a negative is a positive, cosine x sine x. And once again, we're still all over that denominator of 1 plus sine x, 1 minus sine x. Now, what I see is this. I see cosine x and minus cosine x cancel, okay? And then we're left with this. I'm going to combine these. These are just like terms, but I'm going to kind of come up here to do that. So we have 2 cosine x sine x. And you might be saying, man, okay, so if let me write that a little bit neater. I'm sorry, my handwriting's so bad. Cosine x sine x. You might be looking at this and saying, okay, well, if I copy down this, there's not really much else that we can do to simplify. But what if we simplified our denominator now? I kind of skipped out on doing it earlier. If I distributed 1 times 1, 1 minus sine x, kind of foiled this out, what you'd end up with is this. You'd have 2 cosine x sine x over 1 minus sine squared x, okay? This, if you distribute it out, I kind of skipped the steps for doing that part, would become this right here that I have highlighted. Well, 1 minus sine squared x, you're going to find that right over here in your Pythagorean identities. If I subtracted sine squared x from both sides of this, minus sine squared x, or theta in my identity, minus sine squared theta, we get cosine squared theta equals 1 minus sine squared theta. So by rearranging that Pythagorean identity, we can substitute something out here. So then I have 2 cosine x sine x over cosine squared x. Okay? I substituted this out using this identity, and now we've got cosine squared x. Now, this we'll be able to simplify. That cosine squared x, you might see it a little bit better if you rewrite it as such. Cosine squared x is really cosine x times cosine x, right? Well, cosine x over cosine x, that just cancels. And then sine x over cosine x, that's just tan x. And I believe this is going to be your most simplified version of that. So with a lot of these identities, it's so easy to get overwhelmed, but I can't say it enough. This is one of those things where the more reps you get, the more you'll kind of see the patterns, and you'll be able to do these problems quickly and fluently.